So I just want to thank everyone for joining. I know it's not always easy on a school night, and I see a couple of new faces. I'm sure that Jim's presence has brought out some new people interested in this. So before I hand the mic over to Jim, I just want to cover a few small things. Those that don't know me, I'm Julian. About a year ago, Tony English and I started this group, and sorry, I keep admitting people at the same time, so I get mixed up here. So originally it was an OWASP chapter. We changed a new name shortly, changed to the Atlantic Cybersecurity Collective for various reasons. Nothing negative. It was mostly around the fact that we're interested in more than web app security. So now Jay, like I said, he's a co-leader of the group now, but I hate using co-leaders and leaders and stuff like that. Really, the reason this group exists is to provide a place for cybersecurity geeks to get together, share idea, presentation projects, or just hang out, you know. And the last few months we've been pretty quiet, but I promise we're working on a few ideas. Some of you have seen some stuff, and it's a lot. We're going to be doing some pretty cool stuff in the next little while. One last thing, as we often do during these meetups, I'm happy to say that Glenn E. Clark, who's a local author, he donated a copy of his latest book. It's a Security Plus study guide, and I will raffle it off at the end of Jim's presentation. All I ask is whoever wins, just let me know if you're in Canada or the US. I don't want Glenn to have to ship overseas and incur some crazy shipping fees, right? Because he's giving us a book. So yeah, just at the end, I'll raffle that off. So yeah, happy to hand the mic over to Jim for his presentation on the 2021 edition of the OWASP Top 10. And Jim, go ahead.
Hey everybody, thanks for being here. My name is Jim Manico. I'm here to talk to you about the new release of the OWASP Top 10 that came out last month, and to answer any questions you might have about the ASVS release, which came out recently. So what's the OWASP Top 10? The OWASP Top 10, it's a de facto industry standard. Otherwise, de facto means it's not an industry standard. It's just de facto, because the OWASP Top 10 list is meant for awareness. It's really not meant to be a standard that you build a program off of. So why are we here talking about it? Because it is something that the whole industry of web application security and application security points to on a regular basis. So it's kind of like a standard, but please don't base a whole program off of the top 10 list. What's a good use for this? To do talks like this, to give an introduction to web security, to give it as a starting place for someone who needs to learn about application security in the web world. And there's four main project members: Andrew Vanderstock from US and from Australia as well. We have Torsten Gigler from Germany. There's Neil Smithline from the US, and Brian Glass, a data scientist from the US. So, I mean, these are four people I know personally, high integrity. They're just trying to do the best they can to call for data, interpret data, and build a list based on data in application security. Now, we have a very opinionated community at OWASP, right? So two of the items on the OWASP Top 10 new list are from community votes. And the other 8 are based on data analysis, based on a call for data around vulnerability data the last couple of years leading up to this point. That's how this is how the de facto standard, or not a standard, an awareness document. This is how we build it behind the scenes. There's the main URL. I see the OWASP Top 10 as mostly being the same. There's a couple changes. Here's the migration of vulnerabilities from 2017 era, last release, to the current one. So there's some shuffle, and we see insecure design as a new appearance. That's threat modeling. I'm not going to talk about that. I like technical vulnerabilities. Threat modeling is a bit abstract for my taste, but it's critical to help. Basically, you're planning your architecture and analyzing it from a security perspective, hopefully before you make major architectural changes. That's right. You draw pictures and analyze them and tell stories about hacking those pictures. That's threat modeling in a nutshell. But it's really about designing secure software. And so much of security problems are just not individual low-level vulnerabilities, but more design flaws from the way the whole architecture was built for a certain system, that A4 entered the picture here for the first time. We also see software and data integrity failures for the first time. I'll talk about that briefly in this section. And also server-side request forgery made the list for the first time. I'll break that down into detail here today. Server-side request forgery. By the way, the last two are the items that entered the list based on community feedback. The data does not show that a lack of logging harms the world of security. And same with server-side request forgery. But when the OWASP community, thousands of members voted on this, they felt A9 and A10 were critical to security, even if the data doesn't show it for a lot of different reasons. All right, top 10 is what we're doing. Let's talk number 1, broken access control. So broken access control is bumped up from the 5th position. 94% of apps were tested for some form of broken access control. 34 CWEs. What's CWE? It's from the MITRE Corporation, Common Weakness Enumerations. There's a lot of weaknesses that map back to just being an access control problem. Let's break it down a little bit. Hey, hackers, if this is a URL to a message application, and I'm looking at this message, my message that I'm looking at in my inbox, how do I hack this URL to steal messages from other users? What do you think? Who's with me? Is anybody with me? I'm very stubborn.
I know a lot of you know this answer. Come on.
Go ahead, Julian. Why don't you answer? Come on, Julian. Let's see what you got.
Sure. Let's try to. Oh, I can't see your screen anymore. Let's try to. Let's change that number to 2356341 and see what
Julian,
happens.
how long would it take you to write a script to try every number against this URL?
Very short, like not a long time, or just use tools that are already built for that.
Exactly. Are you a full-time employee or are you a consultant, Julian?
I'm a bit of both. Full-time employee.
Julian, if you're an employee salary, you should be able to pull this off script 5 minutes. If you're a consultant or contractor, that's a 2-hour, that's a 2-week project. You with me?
Exactly.
Let's move on. So all Julian's like, exactly. All Julian has to do is edit the number and it'll change the database query to read messages from other users. That's a very simple but very common access control problem that we see in web technology. Now, to fix this, I want to add some identity on my code in the back end. I'm going to add some parameterized query, first of all, to stop SQL injection. That's right. Here's the number of the message I'm trying to edit. And 2 is going to be the user ID. And I get that from a secure session or a JSON web token. But I'm on the back end code running this query to read your message, to show you a message. And I know who you are because you're logged in. So I look at your user ID and I make sure that you're either the owner of the message, the sender, or the recipient of that message, or one of the recipients. And I try to build that into the data layer. So if Julian changes the number and he's not the sender or the recipient of that message, I'm not going to show it to him. And I got a security alert because Julian's hacking me now. So that's what we mean by access control. The other thing is, from a design perspective, as a developer, I really want to build something called a policy enforcement point, an enforcement point of access control in my source code. And I want to make sure that I'm looking at the feature, the activity name, not hard coding roles like all our frameworks encourage us to do. If we code like this, we code it once, we never have to change it again. It implies our policy is centralized and in a database. And it's non-standard in frameworks, but we really need this to build enterprise access control. And this is a lot of design work and a lot of just upfront building of access control functionality to get right. There's a whole industry of companies that provide software components that do access control for your developers. But the problem is a lot of those products handle the easy problems. They don't handle the difficult problems that show up in the world of access control. So from a design point of view, I recommend that you enforce access control by activity or feature name. That data access control issue we looked at with Julian with the changing the number, you have to solve that problem in a more robust way that all developers can utilize relatively quickly instead of having to build it from scratch every time. And I want my access control to be centralized. I want it to be filtered, so all requests have to go through my access control layer. I want to deny by default if anything goes wrong, fail and deny access. I want to use the right data to enforce access control and the right data to drive policy. Some of that data comes from the user, data they're changing. Some of that data is on the server, the policy information. I got to make those choices correct. Like, I don't want to have a cookie that says role is user, because the attacker, I can edit the cookie, change the role, and subvert your access control. So grab the data from the right place. Also, if I'm changing the entitlements that I've configured for a user, if I demote them from admin access, that should take effect right away. I shouldn't have to wait for the user to log in and log out again. And I want to have a good design. Everything should be grouped. My feature groups, user groups, data groups, all of it. These, by the way, are the access control requirements for ASVS. Let's go on a little field trip. I'm in the middle of an OWASP Top 10 talk, but I'm going to go on a little field trip here, and we're going to take a look at the ASVS. Let me go home here. Let's go to the ASVS. This is the Application Security Verification Standard. The last release. So here's I'll dump this in chat for all of you. So this is where I'm at. I'm at the ASVS GitHub repo. The 4.0 directory is the last 4.03 release. There it is right there. But the bleeding edge, where all the most recent updates have been pushed, is in the 5.0 English directory. This is where I live. Let's look at access control. Yeah. So there's not that many access control requirements. Something you can do is help us with this page to add more requirements. We got some basics, right? By the way, level 1, 2, 3, level 1's all app, level 2 is high risk, level 3 is critical infrastructure. And these requirements, except for this one, and this one, are for all apps. So, verify the app enforces access on a trusted service layer, especially if client-side access control is present, can be bypassed. Server-side access control people. Next, verify that all user and data attributes and policy information by access control cannot be manipulated by end users. Yeah, get the data for policy from your server, from the right place. Use principal least privilege. You can read that. So verify the access controls all fails securely when an exception occurs. Sounds familiar, but these are our individual nitty-gritty granular access control rules. This is the bleeding edge version of it, the latest update that you can read right there. Whoa, ASVS, list of requirements. So this is a screenshot from June. There's probably been some updates. Anyways, good access control is hard to add late in the life cycle. So this is something you really want to get right up front. And it's going to take a lot of work to design good access control when you have complicated requirements in this area, like multi-tenancy, data-specific access control, and similar. Here's the cheat sheet on access control. Here's the NIST 800-162 attribute-based access control standard for the National Institute of Standards for the U.S. government and U.S. companies. Sorry, I'm going to stop now. So there's, what else? We got, and I have a link to the access control requirements from the 4.0 branch, and in chat, you can see the 5.0 branch where the bleeding edge currently is. A2, where are we? By the way, if you're a little lost, it's like, how'd I get here? We're in a talk for Canadians, security Canadians, and we're talking about the OWASP Top 10, 2021 on A2, cryptographic failure. And so A2 cryptographic failure, we see this shifting up from one position from 3 to 2, from 2017 to now. We used to call this sensitive data exposure. Sensitive data exposure is a symptom, not the root cause. The problem is cryptography gone bad, cryptography that's broken or in some way. So when you're using crypto wrong, that leads to sensitive data being leaked or some other kind of system compromise. Yeah. So number one, how often should you use TLS and HTTPS in your website, my good Canadian friends? What do you think? I'm going to say always use HTTPS. Anybody want to debate me on that? You want to tell me that you don't need it for something? Anybody want to say that? Anybody? Well, we want to use HTTPS on all connections, right? Is that fair? Anyone disagree? Say something, because I see a lot of excuses why not to use HTTPS. That debate is becoming less and less, though, as now over 70% of the web is over HTTPS. And it's not enough just to use TLS. That's the protocol underneath HTTPS. You want to use it in a well-configured way, and you should not tolerate plain text communication. Also, there's ways to make TLS better. Like you can use another standard called strict transport security, which is a response header that will trigger the browser to enforce HTTPS on the browser side for certain domains. You can even preload as well. And so let's get TLS right. Number one, HTTPS everywhere for everything on the web and APIs as well. So, and your IoT devices as well, everything, transport security. Hooah. So now we're looking at key life cycle. This is because and now that we're moving more and more towards crypto in our applications for data protection and similar, and for identity with digital signatures and JSON web tokens and HMAX, crypto everywhere, you have to manage keys. You have to understand the key life cycle from generating to establishing it, to storing it, to destroying it, and going through the full and replacing it and updating it. And so we want to use some kind of secrets management these days in the world of our crypto implementations. It's not enough to like just throw that private key all over the place and let developers use it. We want to isolate keys to a vault and probably have the vault encrypt other keys that we use to encrypt data in our different systems. And so there's a lot of different strategies for doing applied crypto and key management and similar, but it all comes down to some form of secrets management where our most critical private keys are stored in a vault where they can't be extracted, but they can be utilized. And so the other thing about applied crypto is please don't code it yourself. This is Google Tink, one of the best applied crypto libraries of the current era. It allows me to build a crypto implementation that's going to be cross-compatible between Java, Android, C++, Objective-C, Go, and Python. These are all ready to go. There's a world-class library for data protection. Developers shouldn't be building this from scratch. It start right here. There's also Libsodium, a C-level crypto library, also robust and excellent. So here are some links: the TLS configuration cheat sheet, the SSL Labs project, where you can evaluate the configuration of your own site. There's and test SSH.sh. This is from my good friend Dr. Vetter over in Germany. This is a script where you can evaluate TLS of your own server locally without having to use an internet service for your intranet. And there's the cryptographic storage cheat sheet. And there's also a key management cheat sheet and a secrets management cheat sheet that's being worked on by a new team that we should have that out in a few months. So yeah, crypto is difficult. We're talking about the OWASP Top 10. It's A3. We're going to talk about injection. Now, as part of this topic, we always know that SQL injection is an injection topic, but we've merged cross-site scripting. Now that we have pretty mature knowledge about cross-site scripting, it's no longer its own category. It's rolled under A3. So with SQL injection, by the way, in SQL injection for the first time since 2003, is no longer first place on our list of the OWASP Top 10, the Open Web Application Security Project Top 10 risk list. For the first time, injection is bumped down to 3. We see less and less of an incident rate in this era. And we've also merged cross-site scripting into this category, like I mentioned earlier. So SQL injection is when you let a developer insert untrusted data into a database query using string concatenation, string building. You don't want to assemble a query with a collection of strings. What you want to do, and if you do let me modify your database queries, then I'm going to be able to run arbitrary SQL as if I was your developer's code running that SQL. And they run in the context of your app. Very dangerous. That's why injection used to be number one for many years. This is SQL injection, where I'll bust out my pen right there. You're doing string building to assemble a query. And when you're looking at code, this anti-pattern should pop right out at you. It's a real straightforward pattern. We don't want to do this. This is bad. We don't want to code like that. So how about this? Can I just validate? Let's go back to this. Can I just validate that variable and then shove it in there? Well, how about this? Is this a valid email address? What do you think, Tony or Julian or 10 others? What do you think of this email address? Do you think it's legit?
Well,
I mean, depending on how you would check it out. I mean, just by the codes, I would not authorize it. But again, it depends what you're looking for.
Okay, how about the 2009 formal RFC standard on email addresses? According to the 2009 standard, is that a real email address? What do you think?
No.
Yes, it is. How about the earlier 2003 original email standard? Is that a real email address per that standard? Yes, it is. How about the HTML5 standard, which defines an email address that's a willful violation of the email RFCs? So it's just a normal standard email address. How about that? Is that valid? Oh, yeah, it is. How about this, Tony? Hey, Tony Roy, you ready, Tony?
Yeah, I'm ready.
This is live and active right now. If you don't believe me that this is a real email address, you can email me there. And Tony, if you email me there, which is active, one of my email addresses, I'm going to respond to you, Tony, with one word. I'm going to say, Tony, I'm going to say one word. I'm going to say, believe, Tony, believe. It's a real email address. So think about this, Tony. If you're using input validation, right? If you're using input validation to make that variable valid, that's a valid email address. And if you put that valid email address in the middle of a database query, here's my query. Select some data from the customer table where the email is an email, in quotes. There's my legal email. You can email me. Remember, believe, Tony, believe. And there's the final query where email is Jim and the string or 1 does not equal manico.com. Tony, help me out here. You see this part of the query right here? What does that resolve to? What does this resolve to? 1 does not equal manico.com.
Well, it's true.
It's true. So it's for true now. So select data from customers where email is Jim or true. That email is Jim goes away, and you just dump the whole database table with the real valid email address. Are you with me, Tony?
I am. I was not aware that this was actually a valid email address. I thought in the username you can have special characters at all.
Oh, so absolutely. I swear to you, you can. In fact, let's go on another field trip, Tony, because we're having fun today. We're here.
Yeah, I mean, I'll look up the RFC. I believe you. I've seen pretty weird stuff.
HTML5. I'm gonna see if I can do. I'm gonna go a little bit archaeology with you. I love doing this. So, can you see my browser, Tony?
Yeah, I can.
Okay, go to the HTML standard, and I want the one-page mega version. Come on, internet, give me that one-page version. And I'm going to go search on email. Email. Come on. There it is. Email state email. And if you scroll down a bit, there it is. The following job, this is the HTML. Whoa! This is the HTML5 standard. The following JavaScript and Perl compatible regular expressions is an implementation of the above definition. So here's the most recent standard I know about, Tony, on emails. There's the @ and there's your valid character list. So there's a single quote, there's your dash. That's all I need, baby. It's game over. I got you. So this is a total. So I'm gonna, Tony, you know what we're gonna do together, Tony? Since we're gonna have a moment of co-creation together. Here's what we're gonna do. We're gonna go here and we're gonna go new slide. We're going to pop that. Oh, yes. Look at that. That's awesome. That's a great new slide. We're going to add it right now because we're sharing this moment of creation together. This is the HTML5, right? Yep. Email, regular expression. And so someday somebody will thank us for adding this slide. I'm sorry to build a slide in the middle of the class, middle of a presentation, but that's what we do here. We create together in our communities. All right, there we go. I love it. I'm going to save that. I feel so happy I made a new slide. So it's not, we did have a moment of giving, a moment of receiving too. This helps me. Let's move on. Even valid data can cause injection. And you still want to do validation, Tony. Don't get me wrong, but be careful. Validation's not going to always save you. What you want to do, Tony, parameterize queries. That's what you tell your developers. Parameterize your damn queries. Always parameterize your queries, damn it. And so here's the update statement. Update employees set salary is question mark, where the ID is a question mark. And we're going to bind the salary and ID, and SQL injection is not possible. This is a common construct in Java, in .NET. There you go. In Python. If anybody uses Python, I once did Python. I built a Caesar cipher cracker, and I had a space error. I had one space that was not right, and they didn't compile it. And so I finished that program and swore I would never use Python again because one space and it doesn't compile. What's wrong with those people? What is wrong? But you can do parameterized queries in Python. By the way, some parameterization, you just can't parameterize certain variables, like a table name. But why do you need to make a table name dynamic in a query? Like the user enters a table name and you add it to a query. It's usually a design flaw. Just want to be aware when you can't parameterize, just do ultra strict validation so no special characters are allowed. That hurts functionality, but in the rare case you can't parameterize, it's what you got to do. So one SQL injection, we have a major problem. We have Bobby tables here, which is explanation of how to do query parameterization. We have the same kind of cheat sheet here at OWASP, same basic information. Another form of injection is called cross-site scripting. This is what happens when I can embed JavaScript into your site. Like I'll send a URL to a victim, and one of the parameters on the URL may automatically be added to the user interface. So I see this weird URL. I can change the comment with evil script and send it to you. You click on it, and then that evil script, if the website has this feature, is going to render in the web page and execute script from the attacker. This is an example of cross-site scripting. Attacker injected script into a web page that another user is going to visit. So this evil script is going to run in the browser of a victim that's using the same website typically. I can misuse this in a lot of ways. So I can, for example, by the way, I can also store the attack in the database. I just submit data to your database, like a comment to your customer service. I submit a comment to customer service. But suppose the web app for customer service reps was written insecurely. Then I go read a message from a user. I get their message in my browser, and I just attacked a customer service rep through stored XSS, injecting JavaScript into a web app that another user looks at insecurely, and that JavaScript that I submitted executes in the victim's browser. Now, here's a real attack. For example, we use cookies to store authentication data on the web. And so if I can inject this script into a web page that your customer service rep is looking at, right? This attack lands in their web page. So I build a URL. There's 3 steps here in this attack. This is step 1, this is step 2, and this is step 3. Step 1 here is build a URL that I control as the attacker and grab a copy of the user's cookie. Step 2, build an image. This is not visible. It's just an object. And then do image.source. That's going to make a GET request anywhere on the internet. Images have no rules. So I make a request to Manico with a copy of your cookie. Boom! I stole your cookie. I can also do site defacement. Any of you watch American football? Savage sport, I know. Here's a team in American football I don't like, the New England Patriots. So I say the New England Patriots are full of lying cheaters because they are. They're a bunch of lying, cheating, ball deflating, signal stealing, unethical American football. That's true. So what I do with this attack, I override the body of everyone's web page who hits this attack, and I override the HTML of the body of the whole page and just say, New England Patriots are full of lying cheaters. It's just, I don't really watch football that much. I'm just kidding around, but you can edit this with whatever team you don't like, and this is a defacement, blast the whole page with this. And the point I'm trying to make is with cross-site scripting, I have full control of your page. I can overwrite anything I want, any way I want with evil JavaScript. To stop cross-site scripting is complicated. This is my defense grid. And there's like 3 major categories of defense: output encoding, HTML sanitization, proper use of JavaScript, not to mention content security policy, HTTP only cookies, and trusted types. It's just a difficult thing to stop. And I usually spend, when I'm teaching, I'm a teacher, I spend like 4 to 8 hours just on cross-site scripting if they're building a lot of web pages. We're looking at the OWASP Top 10. We're looking at insecure design now. And I'm not going to spend much time on this because this is not my area of expertise, but this is important. This is a new category. This is a focus on design flaws. If we want to do security earlier in the life cycle, then we need to do threat modeling, secure design review, and reference architectures. So we're thinking about security when we're making major decisions about our software before we build it. So we're looking at the OWASP Top 10 still. A5, security misconfiguration. So this is moving up from number 6 to number 5 for the year 2021, right? 90% of applications were tested for some kind of misconfiguration. Over 208,000 occurrences of CWEs, common weaknesses, mapped to this category. And with the move into the cloud, and so much of our infrastructure is programmatic and configurable, this is becoming a more important category. And we took the older XML issue from 2017, XML external entities. That's just a misconfigured XML parser. We merged it into this category for what it's worth. So let's get into it. What do you say, Tony? Should we get into this? Tony says yes. So security configuration, it's a very broad category. It can span anything to password length, to file permissions, access control decisions, and more. You need to read the manual for the framework, for your deployment environment, for your cloud service, for your your infrastructure. I mean, everything in between. We have to understand how to run through different hardening guidelines and security guides for the different frameworks that you're using, and get the expertise is out there. There are a lot of different guides on how to lock down Spring or Struts or lock down anything that you're working on. It's a matter of doing that research and actually applying it on a regular basis to your software. And so, again, misconfigured applications can lead to all kinds of problems. And here we have, what's this? This is Django being configured improperly that leads to security problems. Oh, yeah, I'm sorry. These are hardening guides. This is Django security hardening guide. How to make your Django Python setup doing really well. Even though if you get one space wrong, it's not going to compile. Anyways, here's how to harden WordPress, which no one should use, but it's the most popular website software package in the world. We got to take it seriously. Here's hardening struts, ASP.core, hardening for Spring. Everything out there has got a guide. How about this? This is the Mozilla TLS configuration generator. They meant to say TLS, not SSL. I'm going to fix that for you. There you go. There we go. There's a Mozilla TLS configuration generator. You pick the software. You pick the config level, the browser level you want to support. Are you doing revocation? Are you doing strict transport? What version of OpenSSL do you got? Boom. There's your config file. So I'm saying is there's help to get this working without having to rebuild it from scratch every time. There's tools to help us get configuration right. Look, here's my site. Go ahead on go look at my site in SSL Labs A+. It's not because I'm smart. It's because I used a configuration generator to do the work for me. Then I checked it out, did a little bit of tweaking, and I got a good server now. So we want really strong TLS configuration. And by the way, this old XML problem, XXE, external entity references, it lets me steal data off your server. Here's a configuration guide at the OWASP cheat sheet series to help you configure your XML parsers to avoid different XML attacks like XML bombs, billion laugh attacks, or XXE that we see here. All right. So this is a huge category everywhere from the framework to the OS to the app server. If you can't verify the config, assume it's not secure. Read the manual and get some hardening guides and go through them. Lock your stuff down. So A, at the very least, we can always talk more about this. It's a good start, though. A6, vulnerable and outdated components. I'm kind of like that. I'm a little bit of a vulnerable, outdated component, but that's all right. We're going to move on. Ignore that. So A6 what is this? What it used to be. This used to be A9. It's brought up. We see a lot of real world events like Equifax. Sorry, Canadians. With Equifax, one of the largest breaches of U.S. and British data about the financial privacy record of U.S. and English citizens. May have been a few Canadians in there too. Who knows? But anyways, some of the biggest breaches of the modern era map directly to third-party libraries being out of date. So we can also look at the NVD database, and we can see that WordPress has an XXE vulnerability earlier this year. I mean, this is recently that one of the biggest website production environments in the world, WordPress, had an XXE vulnerability with the recent version. I can read data off the server with ease. So this third-party library problem, here we have it impacting, this one of the biggest sites in the world, biggest, site deployment techs in the world. This is real. How about Drupal? Here's a major critical vulnerability in Drupal. So it wasn't even Drupal. It was the archive tar library that had a vulnerability and was out of date. How big of a vulnerability was this? How severe was it? Where's this? Yeah, critical. Like probably remote code execution through an insecure zip process. So there you go. Third-party libraries affecting two of the world's biggest content management systems. We just want to show you an example where it's a real impact, where it's real global impact. And there's a lot of different tools you can use. OWASP Dependency Check is a scanning tool that you can integrate into your developer's build environment to check if any of your third-party libraries are out of date. Maven, here's same for Java, this is for the .NET world, this is for the JavaScript world, and you can even use Dependabot with GitHub and similar. They'll just keep scanning your code base, and when they notice one of your third-party libraries are out of date, they'll just issue a PR, a pull request for that particular change. There's a lot of different strategies to keep your third-party components and frameworks up to date, and it's a critical part of web security. Caution, almost every third-party library has this issue. Most dev teams don't focus on it, so use automation to check periodically to see if your libraries are out of date, and you can use an OWASP Dependency Check flagship project to go and take a look at that in your apps. We're nearing the end. Here's identification and authentication failures. Last big topic. This is identity moved down from the second position down to the seventh position. Why such a slide down? Well, because standardized frameworks for authentication, it seems to be helping a lot. It's becoming more standard where I'm not building authentication from scratch. I'm using it from a cloud service or a well-vetted framework or identity provider of some kind. So there's a lot of options to get this right. So what is authentication? Proving a user's identity or a widget's identity. What's our service's identity? What's an authenticated session? It's either a session ID and a backend web session or a JSON web token that's stateless to track a user's behavior. By the way, when it comes to identity, we could spend days on it. There's dozens of topics in the ASVS standard that you can go through. I just want to be clear. I'm going to point out a couple things in the world of identity in our last 20 minutes or so, but this is a much bigger topic than a 1-hour talk. This is a ginormous topic with lots of standards behind it we can read to inform ourselves. All right. How strong should your login be? This is a question I've been asked all throughout my career, and I mostly give an answer from the gut. I think the answer is this. You should use a multi-factor or something like that. But should I use SMS? Should I use an app? Should I use FIDO? Are passwords enough? Customers want to know, and they want more than a guess. So here I have Daniel Miessler's consumer authentication strength maturity model. I'm going to go through this because it's very valuable. This is the lowest level, and this is the best. And I'm going to change a few things. So this is phishing. He can merge these two topics. And this is really FIDO is the better word for it. So I'm going to fix it. So level 1, the worst, is I'm using the same weak password in multiple places on the internet. You're vulnerable to credential stuffing. I steal password data from one site and I use it in yours, right? And so there's that. Whoa. Where are we? Come back to us. We're back. Don't worry. We're back, everyone. Don't worry. So I'm using a shared simple password in many websites. One of my websites gets hacked that I'm using, and the credentials is usable anywhere. That's just called credential stuffing. It's a weak policy. Now I'm using a unique website. Let me try that again. I'm using a unique password for every website. I'm getting better. But if it's a weak password, the attacker can still guess it or use brute force to get to that password. So now we're moving to quality passwords where they're long, random, and have special characters. Now, if someone can dump the password data and crack my account individually, if my password is strong and long, it's a bit more difficult to crack it, but it can be done if the database is stolen. But now I'm not going to use a quality password that I figure out myself. I'm going to use a password manager and generate 40 plus character cryptographically randomly created passwords that I store in a vault. Now, credential stuffing and live password guessing and password cracking is not really possible when I'm using giant passwords. So I'm vulnerable to account reset attacks against other authentication features or stolen tokens or similar, but I can't crack the password easily at this point. Now, this is all AAL level 1. This should only be for public data. If you have sensitive data and you're just using passwords, it's negligence. You got to use multi-factor for sensitive data. So level 2, AAL level 2 from the NIST standard, AAL level 2, we have token-based. Okay, everyone, let's slow down. Boom. Oh, much better. This is AAL level 1. This is AAL level 2, and this is AAL level 3. And so SMS is okay, but it's the worst of the SMS because there's ways to do SIM swapping through customer service at a telecom that's not really secure, or SMS hijacking through malware on a phone. So you can do SMS-based multi-factor, but I recommend that you have another stronger method available that's the default, and that SMS is a secondary multi-factor offering. So now we're at the app level multi-factor. You have an app that generates like a 6 or 10 digit token every minute or two that you use for your multi-factor entry. This is vulnerable to phishing as well, right? So I can phish your password and phish your multi-factor value. Any kind of number-based multi-factor is vulnerable to that. But at the AL level 3, I'm going to use OS integrated biometrics, a smart card, or a YubiKey for the critical infrastructure, a hardware token, and not one that flashes a number. That's not good security. I'm talking about a smart card with a cryptographic key, or a biometrics, which is key-based and key-backed as well. OS integrated biometrics, that's Apple's BS. Let's turn that off for a second. So really, FIDO, it shouldn't be passwordless. This should really be FIDO. So we're talking about hardware-based authentication with a YubiKey or a smart card is really what makes the top of the list here. There are a lot of passwordless vendors trying to move into the space. I think a lot of it is misinformation. Be careful before you quickly migrate to non-standard passwordless authentication. And OS integrated biometrics, be careful. Biometrics is usually reserved for a username, not for actual credentials. I'll leave it at that for now. Here's NIST 863.3. This is the U.S. standard for authentication. Oh, say, can you see? Sorry. I get told to do that by the State Department if I'm talking to Canada. So here I am. I'm in NIST. It's the National Institute of Standards. It's the authentication standard for identity. And I'm looking at one of the third of like a 3-part series in the standard where they're defining authenticator assurance levels. Yeah. So AAL level 1 is for public data, password only authentication. AAL level 2, give me some form of multi-factor. You can even use SMS as long as you offer me something else that's, a little bit better than SMS, like an app level multi-factor. And AAL level 3, this is critical infrastructure, right? This is like, protection of state secrets or like infrastructure for a country or military. AAL level 3 says, prove to me that you have a key. and do a cryptographic protocol. And this is really a hard token, like a YubiKey or a smart card or similar. And here's the workflow that I use. So let's say that, and these are different risk categories: inconvenience, financial loss. Let's cross all these off. And I'm only worried about sensitive data, low, and everything else is 0. Excuse me. Let me repeat myself. We're going to analyze the risk of a certain piece of software. I'm going to say there's no risk other than the loss of sensitive data. That's all I care about, low. So let's go through the workflow down here. Do you assess high for any of the above, right? And so the answer to that is no, because only low for sensitive data. Do you assess moderate for personal safety? I'm definitely not moderate, so no. So now we're going to keep going here. Did you assess any moderate for any remaining categories? Still no. Do you assess low for sensitive data? Yes. Then you should be AAL level 2. What's that? That's basic multi-factor. So what's the point I'm trying to make? If you have even basic sensitive data that you're protecting, you should have multi-factor offerings in your software. Password-only systems are crap, I tell you, crap. We got to move beyond passwords. They really don't do a good job by themselves for authentication. We've known about this for years. And here's a standard. It's not just me talking to you like a crazy person. It's a real US NIST standard that's important. And I don't know if you care about NIST or US standards. You may not. But the intelligence here is reasonable. Europe is 10 years ahead of us when it comes to this. Europe has mandated like AAL level 3 for banking like a decade ago, cryptographic smart cards and similar. So it's not just, I'm just pointing one out that's in my world. We can look around the world. We can see standards like this all over the place that pushes us towards strong authentication. All right.
Just to bug in, Jim, NIST is absolutely in play in Canada also. A lot of the risk assessments that we do are based out of NIST, and we follow those documents. So yeah, absolutely, we know and use NIST. I'm
sure plenty of your researchers in the country participate in the NIST process as well. So
exactly.
That's great to hear. And so should we be limiting the characters of a password? So this is password policy according to NIST Special Publication 863.3. And so what they're saying is don't limit characters of a password. Any printable Unicode character should be accepted. No control characters. Any printable Unicode character, and that should be okay for a password. So we're trying to make it flexible on the user and put the hard work on us as the authentication verifier. And we're also saying 8-character minimum password at NIST. You must support up to 64 so our password managers work. And keep in mind, this is no more than 128 for performance reasons. But the only reason an 8-character password is okay in my world, because we're also mandating, bada bing, multi-factor. So that's in the context, and we should probably do a longer password. I use a password manager, even with multi-factor. But these are our NIST standards, and they're reasonable if you consider that multi-factor is mandated. Here's some, and by the way, here's it's 63B. There we go. And also, don't use passwords for a sole credential anytime sensitive data is involved. We talked about that a few times now. Here's some other rules on passwords, right? Don't limit the character type. We mentioned that. Here's the size. Block words that are contextual to your service, like the name of the company, the type of business you're in, the word username, the word password, your actual username. These are all contextual to your login system. So block a couple dozen of those context words. Also, check against a list of 50,000 to 150,000 of the world's most common passwords. There's many databases on common passwords out there in GitHub and similar right now. Also, map against a list of breach passwords. I use Troy Hunt's service out of Australia. He has a great web service that I can tie into my authenticator. There's basically 600 million unique passwords that have been breached in the last couple of years. Your password should not be on a public breach list. Also, throttle brute force attempts. Get rid of all the special character rules. Stop using security questions. and get rid of password expiration unless there's a reason to do so. And again, force the use of multi-factor anytime sensitive data is in play. And this is there, I'll fix it, B. That's 63B standard. Love it. This is not a good password. It's super common. It's on breach lists. It's contextual, the word password. Don't use this as a password, even though it fits most corporate policies. All right. One more note on password storage, and I'll let you go. And I will stop doing it. We'll go to the last few topics. Argon 2ID is the best way to store passwords. Stop using bcrypt. If bcrypt is old school. If you got to use it with a work factor of 10 and limit the password to 72 bytes. But these days, you should use Argon 2ID with 15 megs of memory, an iteration count of 2, and 1 degree of parallelism. That's the best password storage mechanism. So there's a couple things in the world of identity and to hopefully amuse you. Let's keep going. A8 is about integrity and data software failure. So basically, this is a new category. So much of our DevOps pipeline are running these scripts with no integrity. Like a lot of what I do in a CID's pipeline is I pull down scripts from all these different tool vendors and similar and run them to set them up. And there's all kinds of weird supply chain failures. So at the very least, get the hashes with the scripts, and before you run it, verify them against the hash that you, especially if you're pulling a script down from the internet and running it to set up your DevOps environment, a common thing these days, or pulling it from the internet and setting up your dev environment. So we want to make sure we're doing integrity checking. The other thing is a lot of the vendors that ask us to run scripts in our setup, these scripts are published in their public GitHub repo. So when I'm going to the internet to grab a copy of it, I can check the hash and check it against their GitHub repo to make sure nothing has changed. The more different locations you use to check integrity, the better. Go ask one of your developers who's doing some kind of complicated DevOps setup and ask them how many scripts from the internet they download and run, and you'll see how big of a problem this has become as part of the supply chain problems we see. Last but not least, the A9, logging and monitoring. I'm going to point you to one thing. When it comes to logging and monitoring, there's a new emerging standard at OWASP called the Logging Vocabulary Cheat Sheet. Now, this came from Nike Corporation in the US, and they donated this through their security team to the OWASP Foundation so we can build a standard on this. This is fantastic. You got to log security events. But as a developer, I'm going to tell you, what do you want me to log? I'll log what you tell me to. What security events? This standard gives you this cheat sheet, someday standard, will give you a very clear list of what security events to log so your operations team can detect an attack in progress. Server-side request forgery, I'm done for the day. I'm fried out. So I'm going to punt on this a little bit. And so it's a brand new category. The data didn't show us was important, but the community voted this in, as did I. And if you want to learn about SSRF, go look at the Capital One hack of 2019. Here's a URL from AppSecCo that talks about this in great detail. It's about modifying a URL that was loading a resource and switching it to an Amazon Web Service internal resource that let the attacker steal data. We see SSRF all over the place. Here it is in GitLab infrastructure. Here's SSRF in Microsoft Exchange. Stop installing servers and use Microsoft's Exchange service 365. If you're going to use Exchange, please stop running your own servers. Exchange as a service had this patched in real time, where rarely do any organizations patch fast when it comes to Exchange. I'm going to move on. Moving on. So what do we got here? So when it comes to SSRF, here's a few pieces of advice. All of your internal private APIs should have great authentication, great access control. If you're using a URL as a parameter, if you're letting a user submit a URL that you act on, then validate that it's a legal URL. Also, build URLs safely as a developer. and use network controls to limit what your services can do. Well, my friends, I hope this was helpful to you in some way. I appreciate your time. I hope it's valuable to you. I hope it helps in some way. There's other projects to look at for secure coding. Go look at the ASVS standard and the cheat sheet series. I'm a manager of both of these. If any questions, let me know. And the ASVS is a standard, and the cheat sheet series is like a living encyclopedia of secure coding knowledge. And test. We have OWASP Zap, one of our security testing tools at OWASP. Dependency check to check for out-of-date third-party libraries. And here's our pen testing guide, the OWASP Web Security Testing Guide. If you too want to learn to be a penetration tester on the web, guess what? We're done. It has been a pleasure and honor to have your time and speak to you. My name is Jim Manico. I'm jim@manico.com. If you have any questions, stick a fork in me because I'm done. That's it.